Okay, so it looks like we had high success on the homework. This is the statistics for the problems. So I know that there are resources out there for you just to not really do anything and not think at all and just type in the right answer. And I can't stop you from using that, but then I can see if you know it on the tests. And the tests are worth a whole lot more than the homework. So make sure you can do these problems. So make sure you're actually doing them by hand, and I'm giving you unlimited attempts, so you get the immediate feedback when you get it. Okay. So use this chance to think about it. Our tests are every 2 weeks, so think about every homework assignment and every class as getting ready for the test. This is the review. Every homework is the review for the test, because it's like next week. Always the test is next week or this week. Okay. So and then our first test is a week from today. So this technique, though, undoing the chain rule, is probably the most common technique that you'll use. And as we start learning other techniques, we're going to continually come back to using this even within the other techniques. So this is kind of the foundational, or the first type of technique that's the harder antiderivatives. Many of the other techniques will use this in solving the problems. So we're going to go on to the next technique here. So that was undoing the chain rule. This is now we're going to undo the product rule. Undoing the product rule, that's next. Okay, so recall that the product rule says this, that the rate of change or the derivative of a product, the two functions, say f times g, does not equal the derivative of the first times the derivative of the second, right? That's the common mistake that students fall into. What does it equal? It equals the first times the derivative of the second plus the second times the derivative of the first. And you can reorder that, right? Addition can switch, multiplication can switch. So whatever pattern you have to remember that, I mean, there's, 4 different ways to write this, okay? But this is one way. First times the derivative of the second plus second times the derivative of the first is how you take the derivative of the product of two functions. Okay, so if we were going to kind of undo this, on the left, if we were undoing the derivative, then we'd just be back where we started, right? F times g. Make sense on the left? And then it would be like doing the antiderivative or integral of f g prime dx, and then the integral of g f prime dx. So that's kind of like saying, let's do the antiderivative of both sides, or of all three terms, which is kind of the idea of undoing the product rule. Is this okay so far? Does it make sense? Okay, so these problems, though, you don't get the sum of two integrals. You just get one integral. Okay, so your given integral is something like this. This is the antiderivative that we are desiring. Okay, but when we look at the fg prime, we look at whatever this thing we're taking the integral of. Basic rules, undoing the chain rule doesn't apply. Okay, so it's not just a simple antiderivative. It's not the derivative of something we know, and undoing the chain rule doesn't work. Okay, but if this technique works, then this other one is an easier antiderivative. Like it just requires just a basic rule or undoing the chain rule. Okay, so basically, when we're talking about undoing the product rule, we're saying you're given an integral that's one of the terms of the product rule, right? Because the product rule is the sum of two things. And when you're given an integral, we're going to use this technique. It's like you were just given the integral of one of these, the integral of this one. Okay? And so here's the strategy. So that's what we said. The first thing is we're going to think of fg prime as one of the terms of the product rule. Who's coming in late? What's your name? Was it?
Abdullah.
Just going to write this down. You can sit. It's fine. Can you tell me your name again?
Abdullah.
Okay. So we're gonna be given this one integral, and we're going to say this is just one of the terms of the product rule. So what we want to do is we want to determine f and g. So if what we're given is fg prime, we're going to figure out what the function f is and the function g is. That were the original two functions that we did the product rule on. Okay, and then we're going to compute the product fg. That's easy. Once we get f and g, we just multiply them together. And we're going to do this easier integral, the other one. Okay, and if we can get those two, then we can solve our given integral without directly doing the antiderivative, but indirectly by taking what? F times g minus the result of the easier antiderivative, and that will equal the one that we're trying to find, you see? So we're going to do it indirectly. The one that we want is going to be fg minus the integral of the other term of the product rule. So we never really do directly do the antiderivative of the one we're given. We find f and g, and we find this other integral, and by subtracting those, it'll be this equal to the one that we were trying to find. Does that make sense? We'll do lots of examples, but the idea is we're gonna look at this as when we get an integral. Let's just do an example. Okay, who's coming in late? What's your name?
Jonathan.
Jonathan.
Ruiz.
Okay, thanks. Sure you want to sit there? Can you see the screen?
Yes, sir.
Okay, so here's our, here's the first example. Try this. So first of all, how do we know, so we got the product of two things. How do we know that this is not undoing the chain rule? When we look at this one, why does it not fit undoing the chain rule? Please.
Because the derivative of the product in the function isn't the product outside the function.
Yeah, so what are we looking for with undoing the product rule? G prime f of x times what? F prime x. So here's kind of the way you can know or get a really good idea that you're doing times. Right? That part that we're focusing on, its interior, the derivative of the interior is the other part that we're not focusing on. Remember? So how could we change this so it would be undoing the chain rule? How could you change that so it would be undoing the chain rule? What function would that work for? Can you think of it? Yeah.
4x sine
Sine of
1 2x squared.
what's that?
4x sine 2x squared.
How about just x squared?
No, x squared.
Well, we know how to, but that's just what we clean up, right?
Oh yeah.
All right, so he's saying 4x sine of x squared. Would that be undoing the chain rule?
No.
I'll write it over here. Could you do that in your homework last night? People are nodding. Do you see that you could do that in your homework? Why? Because this out here is just a factor away of the derivative of the inside of this, right? So what would we focus on? What would our first attempt be? So this is going to be our g prime f of x, and this is our f prime of x. So here's the point, that f of x would be like x squared, and f prime 2x. Well, that's just one, that's close enough to this, right? It's the same power of x. And so our first attempt would be minus cosine of x squared would be the first attempt. Okay, so now in the example I gave you, it's not sine of x squared, it's just sine of x. And so because that x is not the derivative of what's inside there, this wouldn't be undoing the chain rule. Okay, so that we need to do something else. And so, of course, it's going to be this undoing the product rule because we're practicing that I'm teaching that. So we want to think of this as an integral of one of the terms of the product rule. Who's coming in late? What's your name? Last name?
Our way.
Okay. So we want to think of this as this 4x sine x as one of the resulting terms of the product rule. Okay? So we got f g prime. So we kind of have to take a stab at it and then work it out to see if we can get it. And then sometimes we'll make the wrong guess at the beginning. We'll have to start over. But if we use an educated guess, we can usually get it on the first try. Okay, so we're going to try f equals. So we're going to figure out what f is and what g prime is in this right here. So when you choose g prime, you want something, you're going to have to find g, right? So you want something that you can get the antiderivative of, because you're going to have to get g. Okay, so really either of these will work. Okay, and so let's just go with f equals 4x. Let's just try this. And g prime is sine x. Let's see what happens. Okay, and then the dx goes along with the one that you're doing, g prime. Okay, so therefore, what would g be?
Negative cosine x.
Negative cosine x. Okay, so here's the deal. So let's just make sure we got this. Just as a check before we go on, 4x times negative cosine x. If we took the derivative of it, what would we get? The first, 4x, times the derivative of the second, which would be sine x, plus the second, negative cosine x, times the derivative of the first, which is 4. So did it work? Did we get the same thing as the integral we're doing? Yes, we got 4x sine x. Okay, so our little setup here is correct so far. And now, in order to solve for this indirectly, we're going to have to do the integral of this. Is that an easy antiderivative? Yes, it is. So we're home free. So we've got f times g. I'll write it out again. fg equals integral fg prime dx. That's what we're solving for, plus integral g f prime dx. So what's f times g? We got our f is 4x, and g is negative cosine x. So as simple as, so over here on the right side, we got negative 4x cosine x. And this is what we're solving for. So we'll just call it A. Plus integral of g f prime. So g is negative cosine x, and that's what we just found over there. Negative 4 times cosine x. So what is our answer going to be? It's going to be that expression minus this one. So minus, this is going to be minus a minus, so it'll be plus, right? And then what is the antiderivative of 4 cosine x? That should be easy.
4 sine x.
4 sine x. So now, the reason the minus sign went away is because we're subtracting, right? A equals this thing, right there, minus this thing. So that's why the negative went away. And then we need, if it's indefinite, we do plus c. If it has bounds of integration, then we're going to apply the bounds to this whole expression. Okay? We're going to put the bounds on the whole expression and evaluate it. How can we check our answer? Yeah, so if we were to take the derivative of that right there, and simplify it, we ought to get 4x sine x, if we were to take the derivative and simplify it. So let's do that real quick. So we're going to take the derivative of this. So how do we take the derivative of this first part? Product rule. So first times the derivative of the second plus second times the derivative of the first plus derivative of 4 is 4 cosine x. So this is the derivative of our answer. And look what happens. Negative 4 cosine x and positive 4 cosine x goes away. And we're left with negative 4x times negative sine x, which equals 4x sine x. Is that what we started with? Yes. Check. Got it right. Okay, questions? So it's kind of like the product rule in disguise, because you're not given the whole result of the product rule, you're just given one. It's like you're given a situation where it's like one term of the product rule, and we're gonna find the rest and indirectly solve for that integral. Anybody have a question? Okay, let's try another one. Yeah, I did. Thanks. Thank you. Okay, so here's our next one. X squared over e to the 6x. Okay, what do we need to do first here? What's that? Factor out.
Or take it out.
Take it out.
The top, split them up.
So if this is undoing the product rule, what is the form of what we think we have here? Is it a quotient?
Yeah.
Is it a quotient? No, right? It's a product, right? So just like with undoing the chain rule, if you have a quotient and you suspect that it's this form right here, what do we have to do first? Make it a product, which would be x squared times. Okay, so or e to the minus 6x. Yeah, 1 over, you can do 1 over. Okay, so notice last time when we picked f was x in the last example, basically, and g prime was sine x. what happened? We were able to do this because when we take the derivative of f, that goes away, right? It's like the degree of that x was reduced, and we were just left with negative cosine, and that's what made it easy, right? So that's the idea with a lot of these, is if you have an x or a power of x times something else, like a trig function or an e function, we're trying to reduce that power of x, okay? So we're going to do the same thing here. We're going to let f be x squared, and then g prime, so we're going to try, so just try. F equals x squared, and g prime equals e to the minus 6x dx. And that would mean that g would be what? So can we do, that's like a little undoing the chain rule. Can we do it in our head now? Is that an easy enough one to do in our head? E to the minus 6x. It would be, antiderivative would be e to the minus 6x, but then the mess would be, clean up the mess, negative 1/6, right? Okay, so we could take f times g, and we could let's just go ahead and do it. So f times g would be x squared, negative 1/6 x squared e to the minus 6x. We're going to take the derivative of that. And fg prime would be x squared times e to the minus 6x, and then we'd have the minus 6 times the negative 1/6, which would go away. And that's what we started with. So we're good there. And this is the term we need now, plus, what's this term? G times f prime. So negative 1/6 e to the minus 6x times f prime is 2x. So this is our product rule that this problem is based upon. They're asking us to find the antiderivative of this one right here, right? And we know in the product rule that this f times this g would give this derivative. Okay? So again, we'll call this our integral, our answer. And so our answer A is going to be f times g minus the integral of g f prime. So A is going to be f times g is right here, negative 1/6 x squared e to the minus 6x. That's fg, right? Minus this one over the integral of this one over here, which would be the integral of this. Or minus the integral of negative, I'm going to combine these, negative 1/3 x e to the minus 6x dx. Okay, so questions to that point? You follow everything that we're doing? Does it make sense? Okay, so what happened? Was it what we expected? What we were hoping for? We were hoping for, instead of doing this antiderivative that we couldn't do, this one would be easy. So here's that one. What do you see? Is it easy? Is it a basic rule, or is it undoing the chain rule? No? But what is it? It's actually another one of these. So what happened when we did this in the first iteration? We did the first iteration of this. We got this x squared. We got it down to an x. But what we really need is it to be gone altogether. So what are we going to do? Do it again. So we have to, on this one, this integral right here, we're going to apply the same technique again. And we want that x then to go down in degree one more time. So we're just left with an e. So you practice that, okay? So just now, forget about all this other stuff, and I'm going to put a red box around it. Now we got to solve this one. It's kind of like we're starting over. It's like a problem within a problem, right? Kind of like we're starting over. So it's like two separate. So you're gonna work on the one that's just in the red there. And actually, let's just go plus plus. Make it easier on ourselves. Let's go plus plus, and then you can just do the positive version of that, and then we know we're gonna add, right? So we're gonna go plus, and that goes away. So now that'll make life nicer. So you're gonna work on this one in the red box, which means you're starting over. You're gonna evaluate this one. Go. You can work together. I'm gonna hand out sheets, but this does not go on the sheet. Okay, this is your notes. You can just leave it. I'll come get the extras. Just leave them in the back. I'll come get them. Okay, work with each other. Check what you're doing. Yeah. There's one third. Oh, 2 times -1/6. Just simplified, right? But then it was minus this with a negative next to it. So that's the 2 times -1/6. Yeah. So these F and G, you're going to do the same thing again. So you want F and G prime. So you could use, you might use new letters. You might use you could use new letters. But it's the same thing. So F is going to be 1. So here we go X squared, so F is going to be 1. X. So G prime is going to be minus. Right, even minus. Yeah, you get it. That's it. They're fine, sir. That's right. Okay, now you're good. Any questions? No, we're applying the first line. Right? So it's not the derivative, it's just f times g equals the one we're trying to solve plus the new one that we're forming. So it's going to be just f times g minus this new integral that we're forming equals the one we want to. Sure. So this thing here is just like a check. This is just like a check, and it also tells us what g f prime is. But in terms of solving the problem, we're using this first one, right? This is what we're solving for. So it's going to be fg minus this hopefully easier integral. Okay? Yeah, no, just g f prime should be 1 6 6 x f prime should be 1/3.
Oh, you're saying for the next one to solve. You'd like the file? Oh yeah, I didn't even put it back. Would you like one over 108? So, well, I think I just subtracting. I think, okay. Okay. And then we have to put it back in. So we just put all that back in.
What's 18 times 6? 108? 108? Is 18 times 6 108? That's what you got?
And the rest. Okay. Yeah.
Okay, that's what I got for the secondary problem. The secondary problem. It's in the red box. That's what I got. See if you agree. Anybody get that? You got that? You agree?
1 over 108.
108. 1 over 108. Because you have 1 over 18, you have the 1/6, you have the 1/3, and then you're going to have another 1/6 when you take the antiderivative. So I think that makes 1 over 108. We're still not done yet. That's just the answer to what's in the red box, right? And then the answer to our problem is going to be this whole thing. So then we add that first term to it.
There's no plus C here.
Oh yes. Well, so we're not done. We're not done. Questions on the problem I assigned to you? Just the integral inside the red box. I'm saying that this is the answer to that down here in the corner. Any questions on that? You agree?
How do you get the wait.
Okay, so do you see that you got the 1/6 and the 1/3 in the integral? That's 1/18. And now when we do the antiderivative of e to the minus 1/6, we're going to have another additional 1/6. And actually you got 3 negatives there, right? Negative, negative, and then with the antiderivative that's negative, so that you end up with negative. So the final answer is going to be negative 1/6 x squared e to the minus 6x, which is this right here, plus what this integral is equal to. So minus 1/18 x e to the minus 6x minus 1/18 e to the minus 6x. Plus c, right? Indefinite, so plus c. If it were a definite, then when we got to this step right here, you'd apply the lower and upper limits to the whole answer. Yes, sir? Is there? 108. Thanks. Okay, those numbers were a little ugly, but we navigated the rough sea. Okay, we're not going to do the derivative of that to check our answer. Because we got 2 product rules to do, right? We have a product rule there, and a product rule there, and then we'd have just a single term there. So we'd have 5 terms to start with. But then what would happen is some things would cancel, things would add together, and then it would all turn out to be this in the end. All right? So you'd have these 5 ugly terms with x's and e's, and when you simplified it, you get x squared e to the 6x. We won't do it. Sorry. Okay, questions on this example? Okay, so let's do another one, and then I'll put you to work. Can I take this? Can I erase? Yeah, sure. It'll be in the video too, if you want to find it in the video. Okay, here we go. Next one. Integral r cubed over Okay, so my first question is, could this be undoing the chain rule? Okay, if yes, why? If no, change it so it could be undoing the chain rule. Okay, so let's practice that. So could you do basic undoing the chain rule with this? And if not, can you make a small adjustment to this integral so that undoing the chain rule would work? Go, so you can do that. Okay, so you thought about it? The 4 plus r squared? Can you use undoing the chain rule? Okay, somebody new. How would you have to change this so that it would work for undoing the chain rule? What would you change? What small change could you make?
R squared would be R to the power of 4.
He's suggesting that r squared would be r to the power of 4. Would that work? Then you could do undoing the chain rule on this one? Yeah, that's what you should have thought, okay? So you should all should have thought that. If this was r to the 4th, that would be good, because then what this derivative of this interior function would have the same power, r cubed, as this one. But that's not the case, so we can't do undoing the chain rule here. Okay? So, yeah.
It have to be r to the 4th, like the whole term underneath r to the 4th divided by 4, because you'd end up with.
No, but we know that in these problems that we work out that factor in the second attempt, right?
Okay, I thought.
So you could have 8 r to the 4th, 100 r to the 4th, negative r to the 4th, any factor of r to the 4th would still work, because we know in that second attempt we work out what that factor is, right? Yeah. Okay, so the first thing to do is make this product. So we're going to do r cubed times, say 4 plus r squared to the negative 1/2. Okay, so we got to think about this. We're going to have an f and we're going to have a g prime. And so that g prime, we're going to have to find the antiderivative of it. So which one f and which one g prime? So remember, so when we pick that g prime, we're going to have to know what the antiderivative is to get g kind of quickly. So that would kind of determine which one we're going to call f and which one we're going to call g prime. What do you think?
R cubed would be G prime.
R cubed would be g prime. Because if this were g prime, then we wouldn't be able to get g, right? All right, so g prime is going to be r cubed. We do f first. So f is this thing, and g prime is this thing. So then g is easy, right? G is
1/4 R to the 4th.
so r cubed. So the dr always goes with the one that you're calling g prime. So then g is 1/4 r to the 4th. Okay, so now looking ahead here, so we know we're solving for this right here. This is going to be our answer. Call it A. Plus integral. G is 1/4 r to the 4th. F prime now. F prime. So that's going to be chain rule when we do f prime. Negative 1/2. 4 plus r squared to the negative 3/2. Done? What else? Times 2r, right? So this whole thing is our f prime. And this was our g. And then f times g is just f times g. Okay? So now we look at this ugly mess. What do we got? We got a 4 plus r squared in that term, kind of in the denominator, or in this composite, and then we have r to the 5th. We have r to the 5th times something with an r squared in it. How do we do? Is this an easier integral? Are we on the right track here? We've got r to the 5th times something with an r squared in it. Easy integral? Easy antiderivative? Undoing the chain rule? Does undoing the chain rule work? We've got r to the 5th, and then inside this composite function we have r squared. Doesn't work, right? So something's wrong. This isn't working. We need a new strategy, or we need a new way to approach this. So we're going to go back to our F and G setup, okay? All right, so what about switching them? So if we switched them, so that would be the next idea. So F would be our R cubed, or sorry, yeah, F would be our R cubed, and then G prime would be this. What about that? Does it work? What's the problem with that? Okay, so what if we did that? We said F was R cubed, and G prime was that other term. Good or bad? Is anybody out there? What's that?
Looks fairly simple.
Looks fairly simple. We got 1 over the square root of 4 plus r squared. Do we have an easy rule for that, or an easy technique to get that? We need G now. We need a quick and fast way to get G so we can keep going. You know, let's do the 1/2, right? And it has an r squared in it. Undoing the chain rule. What would we need to make this undoing the chain rule? What would we need? We need an r up here. We need r to the first.
So I multiply by R square.
No, we can't just multiply by something. So this doesn't work either. So we need to get creative. How are we going to split up F and G prime in this so we can actually get something that's going to work here? Idea.
Could you write it as 2 different rules?
No, but it's a product. It would only be if we were adding, right? So this is a product of terms, so that doesn't work. So how can we get F and G to get this to work? What's that? Chain rule first. What do you mean? Chain rule. What do you mean by that?
I need to work first by doing the chain rule, then we do that other rule.
Are you talking about undoing the chain rule? Chain rule is for taking a derivative.
Yeah,
Undoing. Well, that was the very first thing we talked about. Can we do, and I actually did, can you undo the chain rule on this?
and for the G prime.
For this?
Yeah.
No, but you need an r, right? Because this, in here, you got r squared. You have to have times r to undo the chain rule on that. Do you see that? You need the derivative of the inside along with it in order to undo the chain rule. We don't have an r here, or an r multiplied here, so it doesn't work. Other idea?
Why do you think can't we take the antiderivative of G prime? Isn't it just 2 square root of 4 plus r squared?
Okay, and take the derivative of that. Is it this? Because then by the chain rule, you have to multiply by the derivative of the inside, which is so you need an r. You need an r along with this in order to undo the chain rule. Okay.
Does it have an inverse?
What's that?
Does it have an inverse? Like, wait.
No, I'm not. Oh, this is one of our rules, you mean? No, so it would have to be minus, right? So like inverse cosine or inverse sine is minus. Right? Like it's 1 minus r squared. Or negative 1 minus r squared is the inverse cosine or inverse sine. So that doesn't work, yeah.
You said we needed an r, right?
Yeah.
Can we just separate the r cubed into r squared and move the r to 4?
Oh, here's an interesting idea. If we need an r with this, we've got an r cubed over here. What could we do? We could split this up as this thing times r, and then make f what? R squared. And then we can get g. We could do undoing the chain rule to get this g. Try it. See if it works. So we're going to call, instead we're going to do f as what? R squared. And then g prime is going to be? That thing times R. Now you have a fighting chance. You can actually get G, and then you can go from there. See what happens.
Yeah, yeah.
Oh, yeah, very good.
Can we do that? The new integral? Is it possible? Is it doable? How do we do it? Should know. Should recognize how to do that. Undoing the chain rule again, right? Undoing the chain rule again. You got what? 4 plus R squared underneath, and you got a 2R outside. Perfect, right? Perfect for it.
Is it possible to make
Yeah.
I got plenty of new sheets if you want to start a new sheet.
What's up?
You need a new sheet or you have a question?
What did you call S? What did you call G?